Hi folks, welcome back. So this is number 2 in a new video series I'm doing where I go back and look at the deep literature in human factors and automation and try to relate that to how we're trying to automate human cognition and human labor with AI agents. The first video in the series looked at Bainbridge's landmark paper, The Ironies of Automation. And this, the second episode, is going to look at another very frequently cited paper that offers us a framework called Skills, Rules, and Knowledge by Jens Rasmussen. So the author is tackling a very fundamental question in this paper, which is that as we do work, as humans do work, how do we categorize and define that work? What kinds of work are we doing? What are the characteristics of that kind of work? And if we can understand that, we can then start to look at the implications for automating that work and maybe how best to automate that work. And he breaks it up into these three big buckets: skills, rules, and knowledge. According to the author, these are the three big categories of the kinds of work that humans do. So let's look at each one of them in turn. And I think by the end, you yourself will start having an intuitive idea of how some of these concepts relate to what we're doing with AI agents today. So at the very basic level, we have skills. And skills, this is not skills in the sense of agent skills or skills.md. This is skills in the sense of the original meaning of the word. The defining characteristic of skills is that it is one integrated sensory motor performance by the human. That is a fancy way of saying that you perform skills not just with your brain, not just with cognition, but with your entire body. And good examples of skills are playing a musical instrument or, say, riding a bicycle. These are very fluent activities, very fluent motions, and you're not really thinking in the kind of cognitive sense of the word when you're doing these things. When you're playing a guitar or when you're riding a bike, your whole body is involved in them. And yes, it took you some time to learn that skill, but by the time you're proficient at them, you do them without thinking, and it is one fluid, integrated action. If someone were to ask you, can you tell me the steps you follow when you ride your bicycle or when you play your guitar, you would have a very hard time doing it. So that is one basic kind of work we do. The next level up from skills is what the author calls rules-based work. And as the name implies, this is based on scenario matching and is very much of the form, if something, then I will do this set of procedures. So if I match some kind of scenario, if I happen to see a set of circumstances or a situation that I recognize and that I've dealt with before, then I will carry out a set of actions to deal with that situation or that scenario. And this set of actions needn't always be written down. It could be written down, but it could just be implicit knowledge, tacit knowledge. It could even be something we come up with on the fly, but it's fairly low in terms of cognitive tax that you can come up with it very quickly. And you can see a lot of the work we do, even in daily knowledge work, is of this kind. There's plenty of tasks we do that are fairly repetitive, fairly well-bounded. You have a set of inputs and you have to do some work on it, following some more or less well-understood, well-laid out procedure to get some kind of output. The key criteria is that the scenario has to be somewhat familiar. That's when you can do rules-based thinking. It has to be something you've seen before, that you've dealt with before. Now, moving on, the next level up from rules-based work is knowledge work. And this is the most open-ended, most cognitively challenging kind of work, because here you do not have a well-recognized situation. Here you have a truly novel problem or a novel situation. And what this means is that you have to reason in an abstract way. So examples of open-ended knowledge work are debugging a problem you've never seen before, or if you're a doctor trying to diagnose a set of symptoms that are very rare that you've never seen before. So there is no familiarity in the situation. You cannot just match to a scenario you've seen before and then carry out a set of well understood routines to solve the problem. It is a novel problem, and this is where you have to actually do reasoning and problem solving. So this is true problem solving. Trying to prove a math theorem that is open is a great example of this. All right, so this categorization into these three types of work is the first major contribution of this framework, this paper. The next thing the author talks about is, well, how do you actually carry out each of these kinds of work? Because in order to do this, in order to do anything in the world, you need some mechanism to observe information from your environment. And the author then proposes a framework for the mechanisms via which the observed information from the environment is different in each of these categories. So when we're dealing with skills, the way we get information from the environment is via signals. And signals are basically raw information. They do not have any meaning. They do not have any interpretation attached to it. And because skills are such fluid, integrated actions or performances, we simply naturally incorporate the signal into the way we carry out the action. For example, if you hold a guitar chord incorrectly, you will hear it right then and you'll adjust your fingers in a split second to correct for that. So that's what a signal is. A signal is a raw piece of information from your environment. It has no meaning, it has no interpretation. The next level up, when we look at rule-based information, the way we get, or rule-based work, the way we get information from the environment is through signs. And signs do have meaning attached with them. So they are not just a simple number. They're not raw or unprocessed. They do have some higher level information or meaning attached with them. So an example of a sign might be a gauge, and you know that the gauge indicates pressure, and it might even have a threshold. So you know when the pressure has gone beyond a safe limit. So the sign is much more than a raw piece of information. It is information that has a meaning, that has some concept attached to it, say pressure. It has some significance attached to it, say that it's crossed a given threshold. And most importantly, it helps you act and decide as you carry out your rule-based work. So these rules that you're doing, that you're carrying out, will often be affected by signs from the environment. If the pressure is high, then I should do this. If the pressure is within reasonable bounds, then I can go on to doing something else. So we've gone from signals to signs as we go from skill-based work to rule-based work. And then finally, as we get to knowledge work, we come to symbols. And as we go from signs to symbols, we are somewhat making a break from the real physical world and going into the world of abstract reasoning. So the easiest to understand example of symbols is math. In pure math, if we say something like x plus y equals z, these symbols may or may not have any physical natural interpretation, but because we are able to represent them as symbols, we can construct rules and abstractions for manipulating these symbols. This is how you prove math theorems, right? You define what your symbols mean, you define the rules and constraints of your domain, and then you can solve problems by abstractly manipulating symbols. And the way we perform reasoning almost always is via representing our knowledge and our domain as symbols. So, to summarize what we talked about so far, the author proposes a framework with these three different kinds of work: skills, then rules, then fully open ended knowledge work. And these three different ways that we get information from our environment that enable us to carry out these kinds of work. So when we're performing skills, we pay attention to signals, which are raw, unprocessed streams or pieces of information. If you're doing rule-based work, we rely on signs, which indicate some concept. They have some meaning attached to the physical world or the domain that we're working in. And finally, if we're doing open-ended abstract knowledge work and problem solving, we have to move into the world of symbols, which are purely abstract and help us reason. Now, given this way of thinking about the tasks that humans are doing, the author ends with some implications for how you might design such systems, how you might approach automating these kinds of things. And he has these two or three high-level concrete recommendations. The first one is just to categorize and understand, in that you have to look at what you're doing, what the entire set of tasks and activities are that you're looking at, and you have to understand which of these three categories they fall into. That's important to analyze and understand. And by the way, the main mechanism via which you do that is to observe real life performance. You have to see the people or the systems that are doing this work. And maybe this reminds you of what FDEs are doing today, forward deployed engineers. A big part of being a forward deployed engineer is to shadow and observe the people and processes in your domain before you go on to proposing solutions or automation to deal with it. The second design recommendation is what I'll try to simplify as unification or integration. And what the author means by this is, and what the author means by unification is that you have to look at the entire system. You have to look at the entire system, the entire task end to end, and all the tasks in it, regardless of whether they're done by humans or machines. And that will help you to design the right way to automate these. And the third recommendation is that the interface must be customized to the kind of task you're doing. So as you're trying to automate some of these things, if you think about doing rules-based work or knowledge-based work, your interface has to be customized to it. So if you're doing rules-based work, you have to pay attention to the signs that are used for it. If you're doing knowledge-based work, you have to pay attention to the symbols, and the interface has to represent or show or manipulate these signs and symbols and so on. So that was a quick look at Rasmussen's Skills, Rules, Knowledge Framework. I hope you found that helpful. If you like content like this, consider subscribing, like the video, and stay tuned for further videos in this series. Thanks.